So today, as promised, we're going to take a look at how to graph rational functions. So we're going to put everything all together and sketch a little graph. First thing we have to know is what the parent function looks like. And I believe it was in yesterday's that I gave you a quick little sketch, but today we're going to get some more precise points. So first of all, the asymptotes of the parent function are the x and y axis, x equals 0 and y equals 0. And the only two integer values of this function are 1, 1, so if we substitute 1 for x, we get 1 for y, and negative 1, negative 1. And since I didn't give myself a graph here, just set up our x, y axes. Starting with the points 1, 1, and negative 1, negative 1. And I like to do, for the asymptotes, I like to do dotted lines so that I can see which lines I am not supposed to cross. And basically, once you have those points, you just sketch the curves. Remember, this is a hyperbola. They curve towards the asymptote. So they get closer and closer to the asymptote, but never touch it. So the sketches that we're going to do may not be real precise because we're not finding a lot of exact values for our graph. And because I scaled mine so far, it's actually not going to be real close to the asymptotes. By the time my graph gets to 3, I would have a value of 1/3. So you can kind of approximate a little bit of where your graph should be in relation to those asymptotes. So the first thing we're going to learn how to do is use the parent function to graph transformations. Now we've seen transformations with absolute value, we've seen them with quadratics, so hopefully at this point we remember some of that information about how to shift our function and how to scale change our functions. So step 1, in this case there's just a shift because we don't see any multiplication by the x, and the numerator is still 1, so we didn't multiply anything in the numerator, so we don't have any scale changes on this one. So the shift, anything grouped with the x. In this case, our fraction bar acts like a grouping symbol. Anything grouped with the x is in the asylum. So it looks like a negative shift, but it is a positive shift, or right 4. Shift your asymptotes if necessary. So what this does is it shifts the origin right 4. So here's my new origin. And remember, the asymptotes of the parent function both went through the origin. I don't know where that line came from. So those are my new asymptotes. Shift your points, remember 1, 1, and negative 1, negative 1 from the new origin. So we've got points here and here, 1, 1, and negative 1, negative 1 from my new origin. And then we graph the curves getting closer to those asymptotes. And they should be curves, and it should kind of curve right at the point. This one's a little bit off. I've got the curve a little bit below the point. So let me see if I can graph this one a little bit more accurately. And our second transformation, in the denominator grouped with the x, it looks like a left shift, so we're shifting right 1. And then outside the asylum, we've got that plus 2, so we're going up 2. Now in the numerator, we're multiplying by 5. So that's a scale change. So that was the shift scale change. Shift the asymptotes, so the asymptotes are going right 1 and up 2. So that's, I'm going to plot that as my new origin and draw my asymptotes through my new origin. And then multiply the correct coordinate of those 2 points by the scale change. So in this case, we are not multiplying our x by 5, so we will multiply our y values by 5. So we are going to plot 1, 5 and 1, negative 5. So from your new origin, this is our new origin. So I'm going to go right 1, up 5. So in this case, It's going to be off my graph a little. I should have used each of these as 1. So we're going to say we're about here. And then left 1, down 5. And then same thing, just try and graph those curves getting closer to the asymptotes. Now this one doesn't look like it's getting real close to the asymptotes, but eventually it will. So I maybe shouldn't have curved it quite as much as I did, but they're still getting closer to those asymptotes. Remember, what the asymptotes are is the graph gets really close to them the further away from the origin they get. So keep that in mind.